Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Arin Sime, CEO and founder at WebRTC.Ventures. In today's episode of WebRTC Live, we have a little bit different format than we normally do in here. We're excited to try out something new and would love your feedback on how this goes, as well as future topics and guests are always welcome feedback about WebRTC Live. WebRTC Live is brought to you by WebRTC.Ventures. We are a custom design and development agency focused on building live video applications. We're here to help you bring your application live. You can learn more about us at WebRTC.Ventures. So in today's episode, we have put together a panel of senior engineers from our team at WebRTC.Ventures. And we're going to, kind of like a conference panel discussion here, we're going to go somewhat rapid fire through several different topics. Each of our guests today will talk about a different topic, and we'll have a brief Q&A after each speaker. And then if time permits, again at the end. So the format of this is just kind of what have we learned lately in our team. Most of the time when we have guests on here, they're from other companies, or when we bring in somebody from our own team at WebRTC.Ventures, we focus on a very specific topic, more like a single presenter style. What we wanted to try up here instead is to just have an occasional panel discussion with our team of what have we learned lately? Because in our work at WebRTC.Ventures, we get to work with a variety of different technical stacks, of architectures, of different use cases, of customers around the world in a wide range of applications. And it certainly keeps us entertained, but it keeps us busy. We wanted to share a little bit of that knowledge with you as well in this format. We won't be discussing anything about the specific clients or their specific use cases or any confidential information around that. We always have to be careful about that with our clients, but we can certainly talk to you about what is some interesting new thing or a cool feature or a little tip or trick or something that we have learned related to building and integrating live video into your application. So that's the broad view of what we're doing today in this discussion. And specifically, we will go first with Justin Williams, a senior WebRTC engineer on our team, who will talk about leading unit tests. Then our CTO, Alberto Gonzalez, will be talking about stun and turn and some of the complications around that. And Germán, Goldenstein, another senior WebRTC engineer on our team, will be talking about audio optimization and DTX. So we've got three interesting rapid fire topics for you. Let's get right to it. Justin, go ahead.
Thanks, Arin. So, I think I'm skipping a slide. Here we go. So today, with various tools and services available, developing applications with WebRTC can be done really efficiently. So, for example, many CPaaS platforms offer a wide variety of features which abstracts out the complex details of WebRTC away from the developer. And this enables developers to build new features really quickly. However, with rapid development like this, we do see a need to maintain the code base well, and unit tests are obviously really good for that. They should be written to verify and validate code changes. Might be having a technical issue. Oh, I'll continue. Okay, yeah, so.
No, you're good.
Okay, perfect. We're good. So yeah, of course, unit tests can have their own issues as well. One common issue that we commonly see with JavaScript projects is bleeding unit tests. So a bleeding unit test occurs when the execution of a test affects the shared state between itself and another test. For a test suite with a bleeding unit test, while running each test one at a time, they can pass as expected, but when running the whole test suite together, test failures are seen. So bleeding unit tests can also mask other issues, as they can cause false positives. And that's really tough to kind of decipher and find when you're having these problems. For example, bleeding tests may not have their effects seen until a new test is added, or in a worst case maybe scenario, some implementation in the application code itself is changed. With a larger code base and possibly hundreds of tests, a bleeding test can be very difficult to find and resolve. The resolution can often be expensive, frequently requiring a refactor of the tests and sometimes the application code itself. So this is where factories come in really nicely for unit tests. When writing unit tests, you want high coverage, you want all known edge cases for your program or unit under test to be tested thoroughly. And this can be difficult if the tests are not written cleanly, but a very useful design pattern here is using factories. So factories make maintaining unit tests easier as they provide a lot of clarity as to what the code is doing. Factories are very expressive and easy to reason about. Using factories ensures that resources are created in isolation, shared state is limited, and the common convention of do not repeat yourself is easily attained. When resources are created in isolation, it can be made clear that certain resources are just created for a single unit test. And this pattern helps avoid bleeding unit tests. So here we see a couple tests for our call service class. Two simple tests just to check the behavior that the call service class has on our call model. The first test, we check to ensure that if a call is in an invalid state, the start call API throws an exception. In the second test, we check to ensure that the state of the call is updated as expected when the start call API is invoked. So what we're seeing here is each test using the same shared call model. And this was initially created by the author of this test to not duplicate the code. However, we see that one test is changing the call model during its execution. And this change to the call model affects the following tests if they're run together. If these tests are run in isolation, no issues seen. But running in a suite, they can fail unexpectedly. So for this example, it's pretty clear to see the issue of the bleeding test. However, with more complex tests and large number of tests, this issue can be quite difficult to identify. So here we see a small refactor to the test to resolve the bleeding test problem. So these tests have been refactored to use a factory for the call model. And the call service instance is also constructed before each test. The factory is more descriptive and easy to use for the call model. So the behavior of the factory is very clear, and the tests are a little bit more easy to reason about. Another benefit here is that if the implementation of the call model changes, the factory might not need to change. So as we can see, call service, we've declared it early in the code so it can be nicely identified by our reader as this is the unit under test. The before each constructs the call service so that each test is given a fresh value. And the factory usage clearly states how we want to create a call. And it makes it easier to read and refactor in the future. Factories are a great pattern to use for unit tests. It helps the developer focus on testing the behavior of the units under test without having to worry too much about implementation details. Factories are an easy design pattern to use for many areas of a code base, not just limited to unit tests. Factories can make code easier to read, reduce the amount of code that has to change for refactor, and reduce boilerplate and the potential for bugs. So yeah, here we've solved our bleeding unit test problem while making our tests more maintainable and understandable. Any questions?
Awesome. Thanks, Justin. Appreciate it. So our other panelists hop back in here. If for any of our viewers today, if you have questions at any point, feel free to just put them in the chat and we will definitely address them then. So thanks for covering that topic, Justin. I think it's really important. My first question for you is a little broader than bleeding unit tests in general, but kind of thinking about test automation with video applications. It's different than video testing a static application. Certainly, you've got a lot more dynamic aspects of the application and test, and then also depending on your architecture. We often talk about are you using like an open source media server or are you using a CPaaS? So I'm curious, in your experience, how much should you automate test around your application if you're using a CPaaS? Is there is there value in that, or do we kind of safely assume that they've got that covered? We automate maybe just around it. What are your thoughts?
Yeah, I think for the most part, you want to test as much as possible, but within reason, right? So I think what's most important, you can leverage the CPaaS early on, but you want to make sure that you at least have a unit test to test the core logic of your application. So I think, really depending on where you do want to put the emphasis, and it's unique for every application, but testing your application business logic, that's crucial. So for sure, you definitely want to do that. And, depending on resources and how big your team is and so on, I think you want to take one step further and go from unit test to integration test, and that will involve testing your CPaaS. I think there's benefit to each. Sometimes CPaaSs are really perfect. So then, you focus on your application logic and rapid development that way.
Right. That makes sense. Okay. Germán, Alberto, any questions for Justin?
Yeah, I have one question. What is a good way to identify a bleeding test in a large test suite?
Yeah, for sure, and that's definitely a tough one, and why I think this issue, I wanted to talk about it. You can spend tons of time trying to hunt down a bleeding test. It can be really weird. Sometimes they can happen, once in a while, but not always. But if you have a large suite of tests, maybe in the hundreds, one fun idea you can try is to do like a binary search. So you can split your tests up into two, maybe run the first half of your test, see if there's a failure there. If not, run the second half. If you find a failure in the second half, then you can split that into two and kind of dig down from there. So that's kind of a fun way to do it, although it doesn't always work because it might have different combinations of tests that cause the bleeding test to occur. So if you can't get it, if you can't find it with the binary test approach, then you're going to have to go a little bit more static to investigate the test code. Hopefully refactor to use factories and models. And then one other thing that's kind of major there is that sometimes we might use mocks for a test and reset those mocks between tests. It might be a lot easier to just create new mocks rather than resetting mocks.
Cool. Thank you.
Yeah. It's very interesting topic. It seems also to me, Justin, it brings to surface the importance of doing a full regression test of test suites as a developer before you commit a new test and a new set of code that you've written into the repository, because you might think, I did some refactoring here and everything looks good on my side, but not realizing I just did a refactoring that created a bleeding unit test somewhere else in the suite, which also brings up the challenge if you have a test suite that takes a really long time to run and is maybe too complicated, then you're creating a negative incentive there where your team won't do this sort of, they won't always do this before committing in changes and maybe let some bleeding unit tests slip in that way. So,
exactly.
Great topic. I appreciate it, Justin. Thank you so much. We're going to move on now to Alberto. Alberto, I see you're back with us, at least visually. Is your microphone working now?
I think so.
Excellent. Good. You sound good. Alberto's been doing a live demo for us behind the scenes and prepping for this of possible connection problems, because he's actually doing something very exciting right now, which is he is working on site with a client. And these days with the pandemic, that's quite unusual. So excited for him personally to be able to do that in a limited situation with this client again. However, it creates a challenge that actually leads very well into his topic, which is stun and turn and networks. He's at a co-working facility. Has had a little bit of trouble connecting today. So very relevant. You planned this very well, Alberto. Good job.
Well, thank you. So I wanted to talk about some this kind of pretty popular topic, about stun, turn, and particularly recently we faced some issues with telehealth on-premises platform related with turn, and we thought that could be an interesting topic. So I will introduce it a bit just for those that don't know. Basically, to connect peers in WebRTC, you have this process that is called signaling that just synchronizes the participants that are going to connect. So in this image I'm showing here, user A and user B want to connect. So they need to synchronize using signaling, which would be the server at the bottom. And also within that process called signaling, we need to know how we can connect directly. And because how networks are set up today, we cannot connect directly, which is somehow good because it protects us. But in this case, it goes a bit against us, and we need this mechanism called ICE, which basically is an exchange. It works as a method for us to know how to connect directly to another peer without going through a server. And this ICE process basically provides us a list of candidate connections and paths that we can use to connect with the other peer. And that is done through a stan and turn server that I'm showing here at the top. So the first one is a stan, which is a much more basic server, and just what it provides is our public IP address and port that we can use. And that's what user A is doing in this case. And we get that public IP and port, and we will share that with the other user, and we will be able to basically connect. So this is the first step, and usually that's works really pretty big amount of percentage of the time of the calls work like this, and there is no need for more, but you always want 100% or 90% success. You probably are not happy with a 60% success. So then after, well, this will be at the end of the connection where the two participants have been able to connect through a stan. But then there are some situations where you need a turn server. And this is a bit different. In this case, we are not connecting directly. The user A and user B aren't connecting directly. And that happens due to many multiple issues that can be the firewall restrictions that the specific user has. It can be a symmetric NAT. That depends how the configuration of the network is set up. We might not be able to use a stan basically to connect directly. And that's what, in this case, we are, in this image, we show how the media would flow and go through the turn server. Obviously, that has a cost, and it's something to consider when architecting an application. And also, I wanted to show an example of the issue, specifically in our case that we found, and is that even using turn, you can face problems if it's misconfigured. And this is kind of something we faced specifically, where firewalls would be very restrictive. So it's not only that they are blocking UDP, but they were specifically blocking everything except HTTPS. So you can only use that type of protocol to communicate. So in this case, for example, user A was under that restrictive firewall and was using port 3478, which is the default for a turn server, but we wouldn't be able to receive media back because the firewall wouldn't allow it. So it seems a very obvious case, but when you're building a large application and there are many different dependencies, it's easy to forget about these things, and tests can miss. You can miss this kind of use case. No, it generates this kind of situation of developers saying it works on my machine or things like that. So yeah, I just wanted to mention one, but here in this list I mentioned some other things to consider. Not only the restriction of the user firewall, but also, of course, the SFU firewall if you have any. The number of servers that you use it helps, but it also doesn't. So it's good because it makes the call more robust, but it's also bad because it limits, it makes the user doing more requests. So the establishment of the call takes longer. So better limit the list of servers that you use. Authenticate using ephemeral time limited credentials. Though it seems like clearly it's important because for a stun server, maybe the usage is not that expensive, but for a turn server, here we're talking about traffic going through. So it's pretty expensive. You don't want people to just use it for free. Then there's the part of how we test it. Typically, there is a very famous website that we have used called Trickle Eyes. I'm here showing the URL that lets you verify that your turn or stun servers are working. And if they are working, you should be getting a list of ICE candidates of different types. And based on the types you get, you can verify that is stun working or turn. And one small detail that also might be interesting is adding the turns schema when you pass the list of ICE servers to configure the peer connection, you can pass turn, colon, or turns. When you pass turns, you are forcing TLS encryption. And that, although WebRTC is encrypted end-to-end anyway, even if you just use turn, the media is encrypted. But the user and password that you use against the turn is not. And that's if you don't, especially if you don't manage that turn server, is important security risk. And then there is the geographical distribution for the relays or the turn servers is very relevant, as important as the SFU in this case, because traffic is going probably to go through that. So the same applies here. And yeah, I think that's those are some of the considerations. Once you have the service running and moving that to production, those are some important bullet points. And yeah, that's it. I don't know if there are some questions.
Thanks, Alberto. Appreciate it. So Justin and Germán, if you have any questions, feel free to unmute and ask Alberto.
Yeah, is there a way to test if your turn server supports a specific protocol?
Yeah. So you can, when you use the Trickle Eyes application, you can pass a question mark transport equals UDP or TCP, for example, and you can test specifically that. For example, if you choose transport TCP, in this case, you probably would get just a relay candidate, because the stan is only used for UDP because WebRTC only uses UDP. But for yeah, so you can test it that way.
Cool, thanks.
I have one question. Is there any way where we would just be using stun only?
I think I see a black screen on our Justin, so I can.
Oh, can you hear me?
I don't know if he's talking.
Okay. Are you able to hear me, Alberto?
Yeah. Yeah.
Okay. Justin was just asking if there's any use cases where you can get away with just having a stun server and not using turn.
Yeah. So there are some, and yeah, there is one specific case, for example, for the SFU side. So when you have your media server in a public IP address, that is commonly misunderstood, and people will use turn, but actually is many times not necessary, because you are for the SFU doesn't need turn because it's in a public address and you control their infrastructure. So on that end, usually you don't need. And on the client side, typically you would need, but if it's a specific setup where you know the infrastructure and you know specifically that you are not blocking UDP, or things like that, you could consider avoiding it, using it. But if it's not something you control, definitely you might want to use turn, at least for some edge cases where there is symmetric NAT, I was saying, or things like that.
Nice, that's really cool.
So definitely, if in most general use cases, you're going to want to have a turn server because you don't have typically total control over both, sides of that conversation. But there might be some where you do have, a constrained user base, constrained settings that you can control it. But even I would say, that this gets to a broader piece of advice. I think also of even if you think you're in a situation where you don't need a turn server, test that early, right? I mean, I think that, part of the complications with things like turn servers is that it really hits home that old software development advice of test early and test often, but also test in a production-like scenario, right? Because these are definitely tricky things that if you, especially as we were in this particular case that Alberto was working with, we were working with an on-premise solution. So, it's one thing when you're working with an entirely cloud-based public solution that you're probably going to run into fewer gotchas, but when you're dealing with private networks and on-premise implementations of WebRTC, that probably also implies that there are more network restrictions in place, or at least things that you need to be aware of. And so testing, like any testing, doing it early and often is great, but also making sure that you're doing it in a situation that from a network perspective really mimics what you're going to see in production, whether that's in configuration options or the scale or type of users, the type of calls that you're having. So the sooner you test that, the more likely you'll run into these problems early and be able to fix them early. So, always lots of complication around this.
To that point, I would add that, for example, if internet ISP is blocking media traffic by analyzing the packets, for example, the only way for you to avoid skip that is to use a turn server, for example, too. So in that case, could be so there are many. If you don't control the whole thing, consider this backup at least.
Right. Absolutely. Awesome. Thanks, Alberto. Appreciate it.
Thank you.
All right, we're going to go on to our last panelist today, Germán Goldenstein, who's going to talk to us about DTX. So take it away, Germán.
All right. Thank you, Arin. So I'm going to share with you guys one thing that I have recently learned, which is discontinuous transmission, or DTX. So what is DTX? So basically, it is an advanced configuration for a Opus audio codec that allows to reduce up to 16 times the audio traffic when a participant is silent. So when DTX is enabled, parts of the silent audio packets won't be transmitted to the receiver, saving bandwidth and CPU usage, especially on large multi-party sessions where you typically have a small number of participants talking and the others have the audio on mute. So this is a trade-off. The pros is that we are saving bandwidth and CPU usage. Why bandwidth? Just because we send less packets over the network. And we are also saving CPU usage because the receiver, the other peer, will be decoding less audio packets. So this is a cool thing. A cons is that the audio quality will be a bit lower than with continuous transmission, which is the default behavior when DTX is disabled. Although the difference is not really noticeable. The last point is that I think that it is important to consider that regarding the specification, discontinuous transmissions is recommended, especially when constraints on the network bandwidth are severe, or when you need to reduce the bit rate. So yeah, demo time. Let me share my screen. I'm going to show you this in action. Hold on, please. All right. Okay, so you see my screen, right? Okay, so basically, I have written a small POC, a proof of concept. The idea behind this is to show you the difference between a call using DTX or having DTX disabled. Okay, so by default, as I told you, it is disabled. So let's see the number of packets sent per second. Okay, so I'm going to click here. Do you see my local stream there? Yeah. So I'm going to call the other peer. Okay, as you can see, the number of packets sent per second is around 50. Okay, so I'm going to end this call and start a new call with DTX enabled. And as you can see, the number of packets sent per second for the audio, it's around 3, 2. So as you can see, the number is much lower. Okay, so yeah, it worked. Let me stop sharing. 1 second. And let me put the slides. Okay, cool. Let me go to the next slide. Perfect. So let's see now how can we enable DTX. Just to give you more context, when two clients or peers want to establish a WebRTC communication, they exchange information which is known as the offer and the answer. And part of this information describes what video and audio codecs will be used and the configuration for each codec. So the information that is in the offer and in the answer is called SDP, or Session Description Protocol, and it looks like this, like a large text that can have more than 100 lines. And as you can see, it's difficult to read. So what we need to do to enable this is the following. Firstly, you need to find the line in the SDP that has the Opus codec. So in this case, I'm highlighting the first line. And as you can see, it begins with A equal RTMP map. And you see a number there that is 111. That is the payload type, which is a number, basically, that identifies Opus. So with this number, we need to find the second line that I'm highlighting with the format parameter, which begins with A equal FMTP. And you see there, again, the 111. So once we identified the line, we just need to add the property use DTX equal 1. This 1 means that is going to be enabled. So that's it. This process that I just described of modifying the SDP before attaching it to the peer connection is known as SDP managing, okay? And this is the way we have to set some advanced properties like this one. So yeah, I hope you find it interesting.
Thank you, Germán. Yeah, it's definitely very interesting. Appreciate it. Any questions for Germán from our panelists here, Alberto or Justin?
Yeah, I have one. Yeah, if you show how to edit the SDP, was that the SDP offer or the SDP answer, or you need to change it in both?
It's only for the answer. Basically,
Okay.
it's a receiver-only property that is, it's only in the answer. If you put that in the offer, it's not going to have any effect, basically.
Okay. Cool.
Thank you.
We also have a question from one of our viewers, Francois. Could the reduction in the audio impact transcription quality or success rate if you're using transcriptions in a call?
Yeah, that can happen. So yeah, you need to take care your use case if it's going to work or not, because yeah, the audio quality is going to be lower. So you need to basically test it with your use case. In my case, what I have seen is that it's not noticeable, but maybe for the transcription could be could have an impact. Yeah.
Great. Yeah, the
That's
theme
it.
of today is definitely test it. Any other questions?
I have one question. So does enabling DTX for audio-only streaming cause any NAT-related issues?
No, because basically, as you saw in the demo, the packets sent per second is not 0. We are still sending some RTP. So yeah, it's a number much lower, but it's not going to be 0. So yeah, I don't think so.
Perfect. Yeah. So I guess it'll be keeping those pinholes alive with those lower packets.
Exactly. Yeah. We are going to keep sending RTP, but not the silent part.
Really cool. Thank you.
Thank you.
Thanks, Germán. I noticed when you were showing the difference in the number of packets sent, it was about 25% or something number of packets when you were using DTX versus when you were not. And that was in your proof of concept was a 1-to-1 call. So if you apply DTX in a group call like we're doing right now with 4 of us speaking, I imagine the impact is going to be even greater than a 75% reduction potentially in audio packets. Is that a fair thing to say if everyone's using DTX?
Yeah, I think so. I think it's a good number. Yeah, basically, for example, right now we are 4, and yeah, the number that you are saving, it's much more, right? Because we are 4, and you can imagine in a large multi-party where, as you can see, I'm just talking, and the rest are on mute. This is a typical use case, right? So yeah, for this case, if you are having issues with your network, yeah, it's a good option for saving bandwidth. Yeah, definitely.
Yeah, absolutely, and can be a big assistance in conversations like we're having right now, where the 4 of us are in 3 different countries, 4 different locations across 2 continents, and we have had some minor audio difficulty in this call even, and we're not using DTX in this call. So maybe it would have helped if we did have it on. So yeah, thank you, Germán. Very interesting.
Thank you.
All right. Well, I want to thank all of our panelists today, my friends and colleagues, Justin and Alberto and Germán, for sharing their wisdom with us. And we look forward to doing this again sometime. Really appreciate all 3 of you taking the time to prepare for this. And thanks all of you for joining us and watching this episode of WebRTC Live. If you want to learn more about upcoming episodes, we do these about once a month. You can follow us on Twitter at WebRTC.Ventures, or go join our email list at WebRTC.Ventures to learn more about our next upcoming episodes. So thanks again, everyone, for joining us today for WebRTC Live. Let's take it live.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.Ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.